we need to be able to convert things between polar and rectangular coordinates. So we're going to look at converting points back and forth and also converting equations. So let's start with the point. Here we have a polar point, and actually we want to be able to graph that as well. I'm going to actually graph it up here at the top. There's not a lot of room there. So remember, this is r and this is theta. So I find theta first, which is negative 5 pi fourths, which is over here. And then I count out the radius, 1, 2, 3. So it looks like we have a point in quadrant 2. But let's go ahead and convert that, and actually having that graph shows us how we would convert that, because we want to find the x and we want to find the y, and we know that the length of this is 3, and we know that the angle around here was negative 5 pi fourths. So we can actually use the reference angle of pi fourths and then make sure that we get the signs right in this particular quadrant. So if we set this up, we would have cosine of pi fourths equals adjacent over hypotenuse, and so we can multiply the 3 over here. And so our point is going to be, if we're converting that, our x coordinate is going to be 3 times the square root of 2 over 2, but I'm in quadrant 2, so it's going to be negative. So negative 3 times square root 2 over 2. And then when I do sine of pi fourths, that's going to equal y over 3. So we know that y is 3 sine of pi fourths, which again was square root 2 over 2, and in quadrant 2 that's positive. So there is my rectangular coordinate for that point in quadrant 2. Let's go the other direction. So what if we have a point here in rectangular and we want to convert it to polar? So I'll try and put that one right here. We're going to go square root 3 over 4, and I'm just going to kind of eyeball. That's going to be positive and over here ways, and then I'm going to go down by 1/4. So it's going to look something like this. This is going to be negative 1/4, and this is going to be square root 3 over 4. So if I want to figure out what the polar coordinates are, I need r, which is just simply the hypotenuse. So I could take square root of 3 over 4 squared, and that's going to be 3/16 plus negative 1/4 squared is going to be 1/16, and then I would need the square root of that. So that's going to be the square root of 4/16, which is 1/4, square rooted is 1/2. So I know when I'm converting this to polar, and I'll just put the answer right over here, that my r is 1/2. Now I need to come up with an angle, and I'm going to get that from doing inverse tangent. So it's going to be tan inverse of negative 1/4 over square root of 3/4. And we can flip that over and simplify it. So it's going to be tan inverse of negative 1 over square root 3. Oh, well, wait a minute then. That's something I recognize, because we know that tangents on unit circle were square root 3's or 1 over square root 3's when we did the various values, but it's negative, and I actually know that I'm in quadrant 4 because I have this graphed, and so that one is going to be 11 pi 6, and it just depends on how you want to list the angle, but 11 pi 6 is good, something between 0 and 2 pi, and I found that out because I recognized that inverse tangent. Now let's go ahead and look at graphs. So if I wanted to convert this, first of all, let's see if we can recognize it, because we want to be able to graph things. We recognize that as r needs to be negative 3, but it needs to be negative 3 for any angle, and so it actually is going to end up being a circle of radius 3. So we know how to write the equation for a circle of radius 3, but the best way to do it, if you're thinking of conversions, we're going to square both sides and have r squared equal 9. And then remember, when we convert to polar, and I don't have anywhere to draw this, so I'm going to erase this right here to give me some room. But if I was drawing a picture and I had some point and I'm connecting r with x and y, it's just a Pythagorean theorem. R squared equals x squared plus y squared. So I can replace r squared with that and have my equation of that circle in rectangular coordinates. Now remember the connection, and it just comes from this triangle that I just drew, but we find that x equals r cosine theta because I simply set that up as cosine is adjacent over hypotenuse, and then I multiply the r over, and y equals similarly r sine theta. So when I want to convert this equation here at the bottom, when I have a sine, I need an r in front of it. So I'm going to multiply both sides by r, and that actually takes care of another issue of I had an r and I know what to do when I have an r squared. So that will work nicely. R squared is going to be x squared plus y squared, and then -2, and this is y. So here is my equation in rectangular coordinates. Now I'm going to do the same thing over here, but go from rectangular to polar. So we know x squared plus y squared, that's r squared, and we know x, that's r cosine theta. So r cos theta. So now we have this one in polar, and you could, if you want to, reduce the r's and have r equals cosine theta.